Wen. That's it. That's the whole presentation. This, as you can see, is a Q&A session, except I'm the one asking the questions, and I'm also the one giving the answers. Or when Krista decided to edit my talk, it was a lot less interesting. But this is, I'm sure there's a lot of detail there. Alt title, the fuck they doing over there? So this is generally people ask us a lot of questions about when stuff is happening and like why things are happening. Well, they don't ask why things are happening the way things are happening. They do ask when. And so I'm going to try to answer the when questions and give you a little more context as to why the when is the way that it is. And I hope this explains a little bit about our roadmap, why we're doing things in the order that we're doing things, and what you can expect from Optimism in the future. So we're going to cover a couple main topics. First one is Bedrock. So we've heard a lot about Bedrock today. Wen Bedrock. I'm going to have each section is going to have its own logo. This is Bedrock. Great. So in each of these, I'm going to try to talk about the context. I'm going to start each one with the context as to basically what the thing is, why it's meaningful, and maybe a little bit of context as to why things might take time. So I'll start with Bedrock. Bedrock is meant to be the bedrock, the foundation for Optimism's future. It's meant to be a clean slate that we can use to build towards what we see as like the ultimate roll-up software, right? The thing that is fully secure, fully decentralized, and sets us up for the future that we want, because the current version of our system is not there, and Bedrock will be there. This is a significant advancement in the design of roll-ups. I think Bedrock is really a sort of next generation of the way that roll-ups are built, from the way that we publish data on chain and derive the layer 2 chain from that data, from the way that deposits are automatically injected as opposed to the sort of forced inclusion of yesteryear, to just the way that things reconcile issues automatically to the P2P network, to the design and the consensus execution split. Like, this is really a very big leap in how rollups are built. And so that's sort of it takes a while. You can't do that in a day. And the other thing is that Optimism today works pretty well. Like, surprisingly, holds up under pretty significant load. Even, when we did our first airdrop, I think we saw like 400,000 transactions in a day, and we were like consistently above Ethereum's average TPS and holding up perfectly well. And so we don't really have this intense pressure to ship something new because we can't support the load. We can support the load. Our pressure to ship something new is really so that we can continue with our roadmap. But it's not the sort of thing where if we don't ship it within the next month or two, we're in a position where we can't scale as much as we like. We can handle the load that we need right now. And of course, slow is smooth and smooth is fast. Early, everybody was rushing to get something out the door. And this time around, we were very explicit. We're going to do this the right way. Bedrock is being built from the ground up, the way that a rollup should be built. And we need to be very careful with that because we saw the negative impacts of trying to rush things into production. So where are we with Bedrock today? We have a pretty strong spec, which you can see online on our GitHub. We have a functional local DevNet, mostly functional. Sometimes it breaks, but it's pretty functional, that you can run if you want to sort of experiment with Bedrock today. We went through our first client audit, I believe. We have some really, really dope smart contracts that have been kind of refreshed, cleaned up, took a lot of lessons that we learned from the first version of our system. And we, as of yesterday, kicked off our first contract audit for the rollup contracts. What's next? So we got to finish that contract audit. We have 2 more client audits, I believe, on the docket. We need to go through a public DevNet. migrate the testnet, migrate mainnet. There's a lot of minutia in there that makes this, easier or harder depending on how, let's say, some of these audits go. But that's the basic pathway forward. It's a clear path. We know where we're going. It's just we were taking our time with it. We're doing it the right way. This stuff doesn't happen overnight. So when, right? Again, Optimism works pretty well. So we don't have that intense pressure to ship it right away. And we have a preference as a result for doing things the right way, not doing things the fast way. Even though we want to do it as quickly as possible, we're not going to cut corners because there's no point in cutting corners at this point. We're trying to set ourselves up for the future with Bedrock. And we really do know the negative impact of rushing and the way that tech debt can build up. We've spent a lot of time over the last year cleaning up tech debt, and it can be a drain on us being able to actually get to the future. So realistically, I would say when in the ballpark of 3 to 6 months. I think 3 is like the ideal lower end if things go well, if all the audits go well. And 6 is sort of the pessimistic, like every audit comes back and they say, this is awful, rewrite all your code. There's some critical vulnerability, I don't know, right? So I would put money on this being a very, very solid range. Okay. Any questions there? Yes?
Yes, so does this mean that the stars align in 3 months we are going to have fraud proofs on mainnet?
I'll get to that in a second.
Sure.
Next. Okay. There's also, we'll have room for questions at the end as well. Okay, when proofs. Yeah, whatever. So let's talk about proofs. I think there's a, I think if Optimism has learned anything, it's that the marketing is very important. And we're very good at building rollups, and we're not so good at marketing yet. But what you want to understand about rollups is that proofs are only a part of the security model of a rollup. It's only one part of the problem space is having the proofs. And the mistake, I'll talk about this later, but the mistake that a lot of people made early on is focusing on the proofs first. And the reality is that your security model always boils down to your weakest link. That's fundamentally how security works. You can have an amazingly secure system, but if there's one piece that you can break that allows you to break the rest, you're screwed. And today, rollups, the weakest link that rollups have is upgrade keys. People think that multisigs are, I feel like we haven't had enough multisig hacks recently, but Harmony made this obvious, right? Harmony was a multisig hack. Multisigs are not the security that we want. Multisigs are strictly less secure than this rollup vision that we want. And so if you have these upgrade keys that can upgrade the system within this proof window, your security is actually just a multisig. It's no better than a multisig, and this is where you end up. And getting rid of this is really hard. If you can have a beautiful proof system, but if you haven't figured out a way to get rid of the ability to upgrade your system within the proof window, what you really have is a multi-sig bridge. And that's not a rollup. That's not the level of security that we actually want. And so proofs are only part of the problem space because we actually need to be able to get to this improved security model. So how do we do that? We get really, really confident in our proofs, of course. We get really, really confident in our client code. And then we make upgrades take longer than our proof window, right? So it's very straightforward. In practice, how do we gain that confidence? Well, maybe you would do heavy auditing of both the proof and the client code, which is what we're doing at the moment, right? You get, I think we're doing 3 independent, or whatever, three client audits in total for now. You might be able to formally verify your proof code. We use MIPS. MIPS is well specified. I'm sure that you could probably formally verify the behavior of the MIPS proof system that NorSwap talked about. But the reality is that bugs still happen, and we can't take chances with billions on the line. And there's really only one approach that we believe actually lets you get rid of these keys, and that's client and proof diversity. So NorthSwap was talking about that a little bit. What's the idea here? The idea is to have multiple implementations of your client and multiple implementations of your proof. Why? Because when Ethereum has client diversity, so when there's a bug in an Ethereum client, we get a chain split. But rollups, they don't have client diversity, so when there's a bug in a rollup, it becomes reality. And this can be really, really dangerous because it means that proofs don't protect you from critical bugs in the client. If I have a critical bug in my client that allows you to mint infinite ETH, which Sarek so thankfully pointed out to us in our own client, we paid out a $2 million bounty because of it. Even if we had had beautiful, perfect proofs, all that they would have proven is that the bug correctly executed so that the hacker could correctly get their infinite ETH. That's all it would have proven. And so at the end of the day, even if I had perfect proofs, no upgrades, no nothing, this wouldn't have saved us because we need a secure client, a client that doesn't have bugs in it. And this is why you want client diversity, because if you can have more than one client and more than one proof, and I'll talk about this in a second, you can basically guarantee that if there's a bug in one client, some of the combinations of clients and proofs will disagree, and we can halt the system and say, okay, let's figure out what's going on because there's a bug somewhere. Yes?
What do you think about the current state of the execution engine diversity on layer 1? Because I think it's not that great either.
I don't think it's that great, but I mean, I'll talk about this, but like at least we have options. We can run alternatives, right? So like I said, good job, your bug executed correctly. It seems you have stolen that money fair and square. So we believe that you must have client diversity and proof diversity, and that really beyond just insane formal verification, even if my contracts were if the contracts were formally verified and I heavily audited the client, I don't think I would sleep well at night without proof and client diversity. So how does this work in practice? You have multiple clients, like I said, you have multiple proofs, and you basically run some combination of all of these. So when you do a challenge, you're actually doing multiple challenges at the same time. So let's say we do I'll do a Geth on MIPS, I'll do Aragon on MIPS, I'll do Geth on WASM, I'll do Aragon on WASM, and I'm going to run 4 of these proofs. And if there is a conflict, if 3 of the proofs say that checks out to me, but one of the proofs says that was a bug, or that was an invalid execution, only then do we look at doing emergency upgrades during the middle, or only then do we halt the system until an upgrade is pushed to that proof that results in it sharing the same results as the other ones. So this is really the only model that I think gets you to the full rollup level security and allows you to actually get rid of keys. And we believe that the only way to make this possible in practice is with a deliberate architecture like Bedrock that has the consensus execution split, which means that the consensus client, or so the execution client is very, very minimal. And we can apply the diff of the consensus client, because the most complicated code in this entire system, like the derivation is complicated, but the most complicated code in this entire system is the execution client. Like try building an EVM, it's extremely complicated. But if we can split this out, and we can take a very minimal diff and apply it to other clients, obviously Geth, but Aragon, I guess Besu maybe, whatever you want, whatever you decide you want to apply it to, this is actually viable, right? And it's me, Biggie Smalls, coming to tell you, mo diff, mo problems. So when, the reason I give all this context is because I want to make it clear that Bedrock is a fundamental part of our roadmap to proofs. And without all of the work that we're doing on Bedrock, without all this architecture work that makes it easy to have multiple clients, to have multiple proofs, to plug these things into each other, we fundamentally don't believe that we can have fully secure, trustless proofs. And if you're not doing this, we think you're doing it wrong. We will probably have a basic proof along Bedrock. This was the last time I checked was like a month ago or 2 months ago, so it might be slightly afterwards. permissioned a la Arbitrum, so whatever, okay, only we can run it. Then ideally permissionless proofs a few months after that. The thing, it might be the case that there's an intermediate step there where it's like, it's permissionless, but Optimism is allowed to submit proposals without posting a bond. And so the economics aren't perfect yet until we gain more confidence in the proofs. So you can still, so anyone can submit the proofs, but if we do get challenged, Optimism doesn't get slashed to the tune of millions of dollars, right? So, cool. So that's the basic idea. Any questions on that? Yes.
So, as far as I understand it, this approach guarantees, at least optimistically, that the proofs execute according to a specification, right? In which case, the specification is probably the EVM specification. But what if this changes? What if the mainnet hard forks? What if it turns out that actually you need to adjust the gas prices? Mm-hmm. How do you approach this if you don't have any upgrade keys?
Great question. So I generally don't think we would have no upgrade keys, at least for the foreseeable future. I don't, as you said, the value of these systems is that they behave like Ethereum. If Ethereum starts changing significantly and the rollups can't keep up, that's really unfortunate. What I see instead is that we have long upgrade windows. We say, here's an upgrade, it's going to happen in 3 months from now or a month from now. And if you don't like this upgrade, you can leave, you can take your money, you can go home, or you can, Carl's been messing around in his head with permissionless forking or opt-in hard forks, stuff like that on layer 2. That's the basic model. You would still have upgrades, it would just be in a way that would allow people to get their money out if they don't like what the upgrade is going to do, and you give them enough time. Yeah, Carl, I see.
Are there any changes we need to make to the fault proof?
No, this is the magic. There's no, yeah, wow, that's a really good question, Carl. Thank you. No, the magic of this system is that there are no changes that you need to make to the fault proof. I like to think about this as like an old N64 machine where you plug in a new cartridge. Basically, all you have to do is you hash the binary that you're running and you publish it. So you Merkleize the binary that you're running and you publish the Merkle root on chain. And so if you want to upgrade the client, you recompile, you re-Merkleize, you publish the new Merkle root, and it becomes like a boom, new cartridge gets loaded into the VM.
So do you think instead of multi-sig, the upgrades would be controlled by the governance?
I think that seems likely long term. I mean, I don't know. I don't speak for governance, but it seems likely that that's the case, yeah.
Ideally, Ethereum governs the state transition function, right? So we hard fork Ethereum, we can hard fork all the rollups. At least the rollups are EVM equivalent, right?
Yeah.
So you keep it in sync.
So this is an interesting, one of the older ideas of the we were hoping for with the first version of the OVM was that there would be some opcode or some way that I could actually execute the EVM state transition function or the Ethereum state transition function inside of the EVM, so that if Ethereum hard forks, I no longer need to my rollup node just automatically also hard forks. But that does limit you. It means you can't do a state transition function that's very different. You have to use the same function essentially. Lots of different ways to do this. I got to keep going because there's a lot more stuff, but hopefully that was useful. Wen sequencer decentralization. This is when I started getting lazy. This is the many eyes and arms of the decentralized sequencer. Okay, I think this is one of the short. Well, maybe not. No, it's okay. All right, so sequencer decentralization. Wen sequencer decentralization. So there's two key problems. How do we choose the sequencer? So who is the sequencer at any given time? And how does the actual transition process between one sequencer and the next sequencer happen? So at time t, I'm the sequencer. At time t+1, Carl's the sequencer. Technically, how does that transition happen? Bedrock is the foundation for this as well. Well, gosh darn, you're just the gosh darn foundation for everything, ain't ya? So first question, how do we choose the sequencer? This is somewhat technical, but not really that technical. This is more of a governance-y problem. It's just sort of a, or like a crypto-economic problem. How do you make, how do you select a sequencer? Right now, the algorithm for selecting the sequencer is Optimism is the sequencer. But you can make this as complicated or as simple as you want. Is it an auction? Is it based on staking? There's going to be some long-winded debate, and governance is going to get involved, and a bunch of people are going to have arguments left and right. And it's not really as interesting on a technical front because it's very simple. But at the very least, Bedrock makes it feasible for the L2 system to read the L1 state very easily. We can very easily modify Bedrock so that there's some event that happens on layer 1 that gets emitted, new sequencer, and the rollup node can read that event, and maybe it puts it into the L2 state or something, or it puts it into the state of the rollup node. I guess it should probably put it in the L2 state. Blah, blah, blah. You can, at least technically, who the current sequencer is supposed to be. That's very easy. Oh. The more interesting technical question is just how this transition process happens. The sort of easy example to see why this is a challenge at all is if rollups today, like Optimism today, works where you send a transaction directly to the sequencer, and it has its own, essentially like an own private mempool or like a transaction queue. And if we had a system where there were multiple sequencers, if Carl is the sequencer today and Proto is the sequencer tomorrow, and Carl's sitting with all my transaction in his private queue, and Carl doesn't want to share that queue with Proto, so the transition happens, and now Proto's the sequencer, and all of the transactions that I sent Carl are with Carl, and they're nowhere else. And so these transactions get dropped, and it's a really bad user experience. So you want this very clean transition between one system and the next. So having a mempool is very nice for this. I think at this point the long-term vision is, or not even the long-term vision, like the immediate vision is have a public mempool. If you have a public mempool, you don't have this problem. All the sequencers get visibility into all of the transactions. If a sequencer tries to execute a transaction, but by the time that they try to execute it, they're no longer the sequencer. Next sequencer hops on, they look at the mempool, they start pulling transactions. That only works really well if you have a good P2P stack. We can just reuse Ethereum's P2P stack. Sequencers can share a mempool. This is just like a basic feature that you want if you want seamless transitions between sequencers. There's a little bit of other technical stuff, just making sure that like exactly at the next block I start producing stuff. Like the sequencer just has to be ready to do that. So whatever. So when, definitely after Bedrock, that's like a necessity, right? We're basically saying Bedrock's going to rewrite our stack to make this more viable, to be able to share transactions between one another. So definitely after Bedrock, we're not going to spend our time trying to decentralize the sequencer for our current node. It technically doesn't significantly impact the security model of the system. Like in theory, it could work perfectly well with a single sequencer, but you get better. You have to fall back to L1 less if you have a decentralized sequencing model. So this is sort of just some context as to it's important, but it's less important than things like proofs and things like 4844, which basically give you the most of the security that you want and the fee reductions that users really, really care about. Because if users think that even these systems are too expensive, it doesn't matter how cool our stuff is, it doesn't matter how decentralized the thing is. If no one's going to use it, no one's going to use it. So I don't know. I don't actually have a strong guess. 6 to 9 months was my guess. Maybe longer. I don't think that's unreasonable. I mean, at least for a like preliminary, putting this on testnet and running multiple sequencers on testnet, I don't think that would be unreasonable. Probably at least running this model internally. So Optimism is running multiple sequencers, but it's all run by Optimism. So at least we're testing out the infrastructure for switching between sequencers. I think that's a very reasonable middle ground that I could see happening within this time frame. 4844, let's keep going, we're almost there. This is the scream, except it's screaming at the sheer amounts of data that 4844 lets you post to Ethereum. Why do we care? Cheap fees are great. Users aren't going to use it if it's not cheap enough for users to use it. We want this preferably as soon as we possibly can. But of course, we're restricted by the EIP process and Ethereum timelines. Can't rush Ethereum as much as we can manage our own timeline. At the end of the day, we can't change Ethereum's timeline as much as we would like to. The merge needs to happen first. This is just sort of the political will of the Ethereum space. Merge is going to happen first. So not after that. I believe we're targeting a DevNet within the next 2 months. So we will have a set of nodes, and people basically running nodes that support 4844. The whole point of this is that the goal is as soon as we possibly can after the merge, we want to ship everything. And so that means setting everything up now so that people are happy with the implementation, people are done fighting about KZG, and we're in a place where we're ready to put this into the protocol. Obviously harder to control timelines. There's large incentives to do other things like ETH2 withdrawals. Kind of just depends, hopefully aiming for the merge plus 1 hard fork. Maybe it's the merge plus 2 hard forks. This would be ideal. You never know with Ethereum governance. This just is how it is. All right, Wen ZK. There's nothing there. That's it is there, but I won't tell you what it is. Yeah, this is the alpha slide. Something I want to write a blog post about is the fact that Bedrock is a rollup client, not an optimistic rollup client. When we went about designing Bedrock, the one thing we wanted to do was to forget about the proofs and design everything else first, because we all made the mistake of thinking about the proofs first. And what we realized is you can actually have a beautiful system with no proofs at all, and what you lose is the information flow from layer 2 back to layer 1. And so proofs give you this. But the form that the proof takes, all that proof is sort of like an oracle, that a certain proposal of the state of layer 2 is valid. And the form of that proof can be whatever you want. The form of that proof can be optimistic, right? You have the 7-day period, and if you can do this challenge, and if it passes the challenge, then the oracle says, yes, this is valid. We call this contract that has these proposals the L2 output oracle, right, for this exact reason. But it doesn't have to be optimistic. There's no reason why it has to be optimistic. There's nothing fundamental that says it has to be optimistic. And it can be ZK, right? I mean, it's very viable to basically take the execution of your node, and instead of proving it optimistically, explicitly prove it with some ZK circuit. This is not, if you can prove the EVM, you can prove other machines that are 1,000 times simpler, and you can probably do it very quickly. So this is very viable, and I've talked about this before, but I think it's actually possibly even better than standard ZK EVM approaches for reasons I will get into in a second. Yeah, whoops. No. Okay, well, one sec. Okay, so my argument is that ZK teams currently are focusing on the last problem first. They're making the same mistake that optimistic rollups made when we were doing all this stuff 2 years ago. Optimism did it, we did the OVM, right? What we were like, okay, we're an optimistic rollup. That means the defining feature of the optimistic rollup is that we have to have an optimistic proof. And so we were like, okay, how are we going to get an optimistic proof to work? Well, we have to do all this, this, and this. And the quickest way to get the proof to work is to have this like thing that looks like the EVM as closely as possible. And maybe it's even like almost fully compatible with the EVM. But it's not Geth, but it's close. And now we're an optimistic rollup. And it makes sense why ZK EVM teams are doing the same thing, right? ZK circuits are hard. There's a big incentive to ship. The defining feature of the ZK EVM is the ZK. If you just put out a rollup node and said this is a ZK EVM and you didn't have any ZK circuits, everyone would laugh at you. And so there's this very strong incentive to try to build the circuit first. But the problem with building the circuit first is that ZK proofs are really hard. And so what you end up doing is you end up doing as much as you can to make your node as simple as possible and as optimized as possible so that you can build the circuit faster, right? So StarkNet, for example, Cairo is special built to be easy to build a prover for. That's like the canonical example of this. But there's other teams doing this. ZK Sync is the same idea, right? You don't actually run the EVM. You run this thing that's like basically compatible with the EVM, but it's built to be easier to prove than just proving the execution of the EVM. And everyone is still doing this. I'm surprised. I've been kind of shilling this to people for a long time, and everyone's still doing this. And we did it the same way. And so the alternative that Bedrock makes possible is that instead of proving the EVM, you prove a lower level virtual machine, right? So Bedrock and Canon basically proves the correctness of the MIPS execution trace, right? We talked about minigeth. We talked about the idea of taking this minigeth and we compile it down into MIPS and we run it. And then we do this challenge game back and forth and we find the first step where we disagree, blah, blah, blah. But part of that means we are generating a MIPS execution trace. And ZK works. We can generate ZK circuits for machines. So we can generate a ZK circuit for MIPS. And instead of optimistically proving the MIPS execution, which we have generated, we can explicitly prove the execution with a ZK MIPS circuit, right? So we can just say, well, we have the execution trace, just prove it. Just prove that the execution trace was valid, given the inputs that are on L1. So proving MIPS means you have many, many more execution traces. This is another reason why I think teams are not doing this right now. It seems you need to have a viable ZK circuit. And when the EVM is already a lot of execution steps, but then each EVM execution step takes many, many more MIPS instructions, so, or many, many more MIPS execution steps. So that means that the size of your execution trace increases significantly. But I believe that this is actually not a problem for two reasons. MIPS is dead simple. It's a very simple virtual machine. And MIPS doesn't change, which I think is very important. Why is this valuable? MIPS is dead simple means I can build it very easily. I can have a team of people put a MIPS ZK circuit together much more quickly than I can have a team of people put an EVM circuit together. The EVM is extraordinarily complicated. There's many, many steps. There's not just the EVM. You also have to prove all of these different things around the state transition function that are not technically inside of the EVM. And of course, MIPS doesn't change, but the EVM does. Every 6 months, we get a hard fork, and the EVM changes. And that means that any circuit you built, you need to change. You need to update it. You need to get the updates re-audited. And this blocks you from doing one very powerful thing, which is investing very heavily in circuit optimizations and investing very heavily in application-specific hardware. If you have a circuit that changes every 6 months, right? ZK EVM circuits get re-audited, and if you spent $20 million on an ASIC, you're throwing your ASIC in the trash because you need to go and build a new ASIC for the new circuit. ZK MIPS doesn't change. I can spend $20 million. I can spend $100 million if I want on a ZK MIPS ASIC and basically get to extraordinarily optimized circuitry long before anyone is going to do this for the ZK EVM because it's not worth it because they can't afford to spend all that money just to throw it away in 6 months. And the other side of this is, of course, this is a Web 2 problem. People have been optimizing hardware for Netflix to encode video, to transcode video for the last 15 years. And I'm sure you could hire some extraordinary engineers to build ASICs for you, the same people who've been building Bitcoin ASICs for the last 10 years. So the hiring pool becomes much, much larger. You don't need to worry about having an insanely large ZK team. You have a small enough team to build the initial circuit. You get people to come in and optimize it. You get people to come in and build the hardware. They don't need to be ZK people. They don't need to understand all this. They just need to understand the basics of what it is that they're trying to build. Cool. Gotta go fast. And then best of all, like if you wanted to apply this to optimism, the transition between an optimistic model and a ZK model is actually fully transparent from the end user perspective. We think of the proof as an addition on top, that is that oracle. We can switch out the oracle, or we can even have the optimistic proof running still. And as we start to optimize this MIPS circuit, as we start to decrease, essentially as the time to prove the MIPS circuit starts to decrease, as soon as a proposal goes up on chain, we start generating the proof for that proposal. And hopefully it doesn't take 7 days to generate that proof, but even if it did, if it took 6 days, it'd be an improvement. Because after 6 days, we post the explicit ZK proof, and now the withdrawal time, instead of being 7 days, became 6 days. And over time, as we optimize more and more and more, the withdrawal time gets lower and lower and lower and lower until you're down to on the order of minutes or hours withdrawal time. And users don't even know that there's a ZK system happening at all. Optimism just sort of suddenly becomes ZK. Which is an amazing model because it means we get to build the chain and not have to worry so much about changing the chain to be able to support the circuitry. So when, I don't want to make a bunch of claims about exactly when I think this sort of thing would happen. Bedrock is obviously a very big piece of making this possible in the first place, so definitely not before Bedrock. That would make no sense. It's never going to happen. And we still have this philosophy that proofs last. Proofs last. Proofs are the thing that you slap on top. And so there's a lot of other stuff before we even get to this idea. It's still a very early concept. Of course, I believe it's viable, but there's we don't know the amount of time it would take to optimize a circuit like this down to the level where it's actually feasible to run these proofs. So it could take a long time. I don't have a clear timeline. This is not something that we are actively sitting down and thinking about right now and working on right now, but it is something that we have thought about and explicitly the Bedrock design is built to be agnostic to the proof that you put on top. When end of this presentation? That's for you to decide. Q&A, real Q&A, if people have explicit questions, or this presentation ends, immediately on, I don't know. Depends on if people have questions. So question time. All right, okay, Proto.
Do you think we'll switch to risk and not build the MIPS ZK circuit?
That's a good point. So, right, risk zero.
Risk V.
Risk V, yeah.
Yeah, because MIPS is a risk.
Risk, yeah. We're talking about that risk. And we have, obviously, risk zero is trying to build a ZK risk. I'm sure they're doing it for their own reasons. But if risk zero succeeds, and we can make sure that Golang has... so if risk zero succeeds, Optimism is automatically a ZK rollup, sort of, with some extra work required to generate the risk execution trace and then prove it. But essentially, if risk zero succeeds, and hopefully appropriately open sources all of its work and doesn't put it behind a business source license, then this works. And we don't have to do the work of building a ZK MIPS.
Yeah, for the history around the MIPS choice, the original idea was to use risk. But Golang a year ago did not support risk in the way it does now. So the obvious choice is risk Friday is not available, is to pick something as close as possible in a risk family of instruction sets and get to MIPS.
Right. And MIPS, because it's simple, it's small, you can build it in 400 lines of Solidity on chain, and every line of Solidity code opens you up to new problems. So
we're on 40 instructions, all operating a few bytes at a time.
Yeah. Yeah, it's very small. What up, Norcy?
I want to make a comment, maybe spark a debate. So I'm bearish on the public mempool.
On the mempool?
On this big ballpark.
Right.
I think there are reasons to keep it private, and there are also alternatives that.
Yeah, I could see a future, like, I think in the very short term, practically, as soon as Bedrock goes live, it's possible that there will not be a public mempool right away. There are some
I
people.
think we're pretty much decided that.
Okay, so I guess it is pretty.
Kelvin is going to be very angry.
Okay, so no, then I won't commit to a public mempool because Kevin has waved his wand and decided. But essentially, the TLDR is there are projects that are relying on the behavior of Optimism today. You get this nice private communication with the sequencer. So as we try to, no, it's not synthetics. But there are, end result is we need to figure out a transition path. We need to figure out, is it a private mempool? It probably will be at first with the one sequencer, but maybe is it a private mempool among the sequencers? Does that just make it public in the end? You know, can we, at the end of the day, we're thinking about our vision. And so if we need to help projects transition away from this current model, that's what we'll do. We're not going to like shoot ourselves in the foot.
Yeah, I think a key concern is that if you have public mempool, you kind of front running the people really don't like it. It's so legal angle, it's a bit shady. And so, yeah, the idea that when we have a good experience for users that they like, while making the system work and being decentralized. That's the thing.
Right. Unfortunately, there's this constant tug of war between decentralization and the user experience. And it's very, very easy to bank on the user experience at the expense of decentralization. You have to figure out where you want to sit on that line. What up?
I asked a question to ask L2B that question. What do you guys think? Should there be mempools? Does any L2 have even a public mempool right now?
I mean, it depends on how you define a public mempool. If you define a public mempool as forced transactions that are equivalent in like sorting with what sequencer posts, then no, I guess. But that would be one option, right? But I think this goes on to a UX question that wasn't discussed, which is you don't get instant confirmations, right? I think the reason why you would want a single sequencer is not really to combat MEV, sorry, to combat MEV, but because the single sequencer has the biggest opportunity to do MEV. It moves the MEV from anyone can do it if they are fast enough to this one guy can like rake in billions in profit. And so I think the motivation was to rather have a better UX where, because it's a single sequencer, you know what the state will be prior to posting the chain. And rollups are actually faster than L1s, because if you have a decentralized sequencer in that anybody can post batches, then rollups are slower in terms of the time from you making the transaction, you signing the transaction and getting executed. Go ahead.
Right, so you get certainty from the sequencer if there's not as much complexity in selecting transactions. However, I do think this is like a contradiction with the promises that many layer 2s make about like finality or like instant finality of transactions, because it creates certainty but not finality, right? Where a rollup or any layer 2 is always subject to layer 1 for confirmation of data, and to keep the chain alive, you have to always enforce the layer 1 activity and priority over anything that the sequencer might not be able to publish to layer 1. And so, yeah, like the question I want to make is like, what do you think of this trade-off where maybe you should not aim for perfect instant finality if you can improve liveness of your rollup? Or is it just, is UX just that important that you shouldn't be a layer 2?
So let me rephrase the question to, if you were building a rollup, what would you do with the sequencer?
Right.
And if I was building a rollup, I would just have the canonical transaction chain accept, open up the post batch or append batch, however the function is called, to anyone. And so it could be used for both forced transactions, because you could just do a batch of one transaction, or you can do a batch of however many transactions you want, and then just figure out the UX on the application level and not on the smart contract level. This would be super easy to implement. I don't see any hard security risks, government risks.
There are a few risks to this. I would say that actually, when people were originally designing optimistic rollups, that was the design that people were thinking about. The biggest issue, the number one issue, is that you run into this really nasty gas price auction, because if there are multiple people trying to post batches at the same time, let's say they're posting different batches, right? We're pulling from some public mempool, and we've all generated the batches in some different order because we're sorting by different things. Then you try to publish your batch, and I try to publish my batch, and only one of us wins. But the problem is that the cost of publishing batches, the vast majority of the cost, and in Bedrock, almost the entirety of the cost, is dependent on the call data. And you've spent that no matter what. Whether you win or lose, you've spent the full amount. There's no revert that's going to help you not spend that gas. And so you end up with this problem where essentially you create this huge priority gas auction where multiple people are competing because they really want theirs to be included, because they're the only ones that are going to get the rewards for this. And unless you have some system where essentially everyone's fees are increased because we got to pay for all the uncles that were published but didn't get submitted, and it just becomes this really nasty thing where, as a result, your UX your UX gets worse and your fees get worse at the same time. And so this is the original motivation of okay, what if we just let one person do it at a time, and we give them a space of 10 minutes where they get to do it, and then the next person gets to do it, and the next person gets to do it, and at least you know that person isn't that you're not going to have to go through this gas auction. You get the cheapest possible price that you can get the data on chain. Great, that's what you want. And so you can still have a decentralized decentralized sequencer model that where you're not sacrificing user experience, for instance, right? Where you even get instant confirmations by just making it a system where the sequencers have time slots long enough that they can provide this good user experience, but not so long that they can basically censor users dramatically over into the future.
But do you think the trade-off of having to have a mechanism of governing who is the sequencer and how long is the window and stuff like this is worth it? Wouldn't it be possible to solve the problem with just having sequencers coordinate off-chain on this, right?
Potentially, but still quite hard. I also have another point where with kind of the EVM state model, it's kind of inherently unclear what a transaction does and means without the pre-state of the transaction. So basically we end up in a world where you can just kind of transactions are ordered by on-chain behavior. You get really weird gas semantics and just state transition semantics that just doesn't work. You wouldn't be able to do refunds. You'd have a lot more checks. I could talk with Eric about all the ways that it breaks down, but I think it really breaks down if you don't kind of execute the transaction and then submit them.
I guess it's another approach other than the time slots would be slapping a tender limit on top and just having 2/3 of the POS validators to agree on the order. I think ZK Sync is doing that. So, and I think it's pretty fine approach. The other thing, because I think we missed the previous talk about the Bedrock, but I actually like the single sequencer being the single block producer, but multiple, verifiers or whatever the name is that just create a mempool. I think it's the right decision, and with that you can still have a pretty fast, soft confirmation, soft finalization of like 2 seconds or something like that, right? So I think it's a good trade-off.
My question was like, you mentioned the slots, the question is how do you choose who will work?
Yeah, so that's just one of the fundamental questions is like, how do you choose who the sequencer is at any given time? And I mentioned it briefly, but the answer is like, this is a big governance debate that people need to go and be at each other's throats at for a while. You have certain properties that you want. There's certain other incentives in play as well. It's the question of like, how much money should the sequencer make compared to how much money should the protocol capture? And
no, I mean like in this, like it's one sequencer now, next another.
yeah,
It's like round robin, or how would the protocol decide now it's this sequencer that should?
right. So I guess that's the point that I'm trying to make is like, maybe it's an auction that determines who the next sequencer is, or maybe there's a set of like, maybe at first I could imagine that after we test this internally that we specify a list of like a few people to test out this decentralized sequencer infrastructure, and like it just hops in a round robin between these people. There's so many different options for how you do this. Carl jumping around in hot takes.
I'll give you my hot takes. My hot takes is there's like 2 really useful, or 3 useful phases. One of them being optional. Phase 1 is sequencer decentralization, where governance just controls a single sequencer address and can update that address, and you just have like a shitty transition, but it happens. Okay, that's one. That's like the easiest. That's step 1. Then step 2 is governance curates a list of sequencers that round robin goes between. Right? That's pretty straightforward. And then step 3 is the same step 3 that I put in all of my things, which is we upgrade Ethereum to better handle sequencers, so we have a native way to like sequence, and it works well. So we can get rid of this whole fucking sequencer concept. Because like the whole point is like we gotta minimize the protocol until it's like beautifully, like literally the most beautiful piece of software. And like to be honest, L2 is super janky. Like it's literally built to like subvert L1 governance. But like for God's sake, please just give us throw us a bone. Like we'll build how to work in for 5 years. Just throw us a bone after the 5th year, and like we'll get there. Anyway, so those are my 3 years.
I think in like principle it's impossible to have like a permissionless system where you can become a sequencer for a period of time. Because then the MEV is exactly maximum. Like a solo sequencer for like 5 minutes would prevent liquidations in DeFi, would prevent Oracle updates, would front-end Oracle updates. Like if it's a permissionless system, then the system is basically destroyed after the first solo sequencer sequences for 10 minutes. It's like that. I think so.
Yeah.
We need some social consensus. I think on top, right? I think there's some rating system, right?
Yeah. So that you would probably address that issue in like phase 2, where you have a round robin of some select group of sequencers, and then phase 3 you get the ultimate version, which is like L1 level of liveness, unless we don't want L1 level of liveness, which I think some of it.
Yeah, I'm not sure that L1 solves it, because what it says is that if it's completely permissionless, it's what we were talking about earlier. It's a form of punishment. You want to be able to punish the bad actors somehow, and the level of bad behavior is really hard to describe formally. And so it's hard to automate, and that's where the social governance comes in. If it's a set curated by governance can say, hey, objectively, like we were talking through, you're a bad actor. We're gonna kick you out, we're gonna slash you, whatever.
But the problem is, even if it happens once, you might be in a pretty bad shape. Like you cannot put the bond on like third, second orders of like effects of like from running an oracle.
Right. But it might have to be that the sequencing, like the windows are not 10 minutes and they're more like
There are two parameters.
30 seconds, you know?
Hold on. There are two parameters here. There's one parameter to enforce the inclusion of layer 1 things into the layer 2 within a very short amount of time. And there's one other parameter that makes it available and final on layer 1. And the first parameter that forces deposits to be processed within a certain amount of time can keep the layer 2 alive in some of those cases.
Right.
Yeah, sure.
This is true. And by the way, just if we believe that the way that L1, like the block production of L1 is not sufficient for like preventing censorship, then we need to be, then IMO and like the ultimate long-term thing, then we should make a case for why L1 should change the way that it's doing its, providing its transaction inclusion to have better properties. Unless, or at least split it out. The key reason why I go back to L1 is just because it's really ugly. If the L2 if L2 has a liveness failure, that is not correlated with L1 liveness failure. Because now you have weakest link security for your liveness assumptions, which is way better than weakest link security for your safety assumptions. So we're already way better than the side chains. But nonetheless, it does not make sense to me to have like a really we're trying to build a rollup that is like indestructible. So like even a just like an uncorrelated liveness failure is like that is suboptimal, and we should move away from it. So like if we need to have an actual on-chain list of like valid sequencers, like I would argue that we should have L1 curate that list or something, right? So then L1, if it ever gets corrupted,
So it would just hard for people on this side.
I'm not saying that I have any suggestions here, but this is the kind of like longest one.
Because you can make the point that
All right.
you shouldn't put the social layer.
Wait, I'm just going
We
to,
started with a mempool question.
yeah, this went all over the place.
Crazy.
I think
I always do it like this.
unless there are other directly related questions, I think we can cut it and just continue conversations separately, because I think it's, cool. All right, boom, done.